Hey, my name is Anthony Carroll, and today we're going to be building a mobile workbench slash fold down miter saw stand. So let's get after it. Alright, so the first step is just to cut everything down to size, so I'm just lining up the ends, throwing a squeeze clamp on it, and just barely kissing the other end of the board with the blade and making my cut. Now that everything's been cut down to size, we're just going to remove the factory edges of the 2x4s by ripping them off. So I'm taking a 1/4 inch off each side, and that'll leave us with a 3-inch wide stock so we can accurately measure, and all the joints will hopefully line up a little bit better. So while I'm ripping everything down to size, let's talk a little bit about the design process. The first thing I do is just sketch everything up. Now granted, this is just an initial sketch, and the sizes and dimensions will probably end up changing, especially once I throw it into Shaper. So like I said, I like using Shaper 3D to do my final design. One, this gives me a very accurate 3-dimensional rendering of the product, so I can see it from multiple angles. I can develop all my cut lists from this, and like in this project, it lets me see if something isn't quite lining up, or I don't think it's going to offer enough support as it's currently designed, and I can make those revisions prior to actually cutting into the stock. And doing it the old-fashioned way of just oops and then cutting a new piece of lumber. Alright, so now that we got all the framing cut to size, the only thing left to do is throw a couple pocket holes in 2 of the uprights, and then we can start throwing everything together. So assembling the base. Everything that all the framing is going to be held together by GRK number 9 2.5 inch wood screws. These first 4 pieces that I'm going to throw together here are going to make up the center of the base and will really be what everything else is kind of built around. So I want to try to get it as square as possible. I'm using a little 12-inch speed square here and a couple clamps to hold this angle at 90. I'll pre-drill, countersink, and then run the screws into it. Now that the base is put together, I'm just pulling a tape across, measuring corner to corner just to see and make sure everything is square. And luckily enough, it was. Moving on to the uprights, it's more of the same, just a speed square, just to hold it at 90, pre-drill, countersink, and then screw it together. Now that the base is together, I can save my back and get off the floor. I'm not as concerned as it getting out of square, so I wanted to use the concrete floor just because I know that is true and square and pretty flat, or at least it slopes evenly. So I want to laminate these secondary leg uprights onto this board, or onto the primaries up here. What that's going to do is just provide a little bit additional strength, especially when you put the cross piece up top. It gives it something to set on to support the weight. Now these will get laminated, screwed and glued to these uprights. Worst case scenario, if I have to take this thing apart, as long as no glue drops down and attaches to the base here, I'll still be able to unscrew this whole assembly, and then only these 2 pieces will be joined. So I'm using Titebond original here, spreading it out. I'm sinking about 6 or so fasteners, 2 at the top, 2 at the bottom, and 3 or 4 down the center of the board there to hold everything into place while the glue dries, and really to keep it as rigid as possible. Now that the legs are done, we're just going to take and throw the top horizontal piece up here, just using a couple screws on either end. Now granted, I went through the entire stack before cutting my pieces out to try to find the straightest boards possible for this piece as well as the base.
So moving up to the front and doing the same thing. This runner only goes about 20 inches or so into it to leave room for the actual miter saw. I'm just using a speed square just to make sure it's at 90, a few clamps to hold everything together, and now we'll set the distance for everything else later on in the build. Alright, so we threw in a couple more pieces down here at the bottom. There'll be a few more support pieces that go in later on, but you know, it's pretty straightforward. Just pre-drill, countersink, and screw in.
So we're almost done framing this one in. The only thing we have left are 4 pocket hole screws to hold this last remaining upright support. When you're installing pocket screws, you need to face clamp or use some sort of a clamp to keep the faces from shifting. As you're screwing in the pocket hole, it has a tendency to want to push the direction, or push the board in the direction that the screw is traveling. So I got the cart flipped over and then the casters laid out. So the casters I'm using are a 3-inch swivel with a brake. I got these from Harbor Freight. I think they're on the after Christmas sale, so they're a few dollars each. Assembling the base for the miter saw is pretty straightforward. So it's just, in my case, based off the dimensions of my saw, it's a 24 by 17 box. I went and took the cross braces and drilled a 3/4 inch miter slot. I'm sorry, a 3/4 inch hole with a Forstner bit all the way through. I'm going to go through and take and clean up this shoulder here. That way it's just a U-shaped hole that the galvanized steel pipe will slide into. So now we're just slapping it together, everything test fit. There's a little bit of play in the steel pipe, but I wanted that. We're going to affix the steel pipe to the back of this stud here with these little brackets specifically designed for it. That's what's going to be carrying the majority of the weight versus just these 2x4s. Now we're breaking down our plywood into something a little bit more manageable. I'm gonna rough cut everything, leave a reference edge, and then finish everything, actually cut it to size using the table saw.
So that could have worked out a little bit better, but nonetheless, we made it work. So again, like I said, I'm cutting everything down on the table saw to its final width here, or really just cross-cutting this piece so I can trim everything down to its final width using the feather board and removing all the factory edges here. Now that we got the width established, we just turn the board around and do our cross cuts so everything's to its final width.
All right, good deal. We got all of our panels cut to length and width. Last thing we have to do is throw some pocket holes in the vertical panels there so we can affix them.
So mounting the panels that we just drilled the pocket holes in, again, same thing as before, face clamping it using a little Craig jig. Now I'm also using a pocket hole clamp, also from Craig, just to make sure everything's kind of pulled tight.
All right, now that we have the left and the middle panel installed, the only thing we have to do is work out the height of our miter saw so it'll be flush with the work surface. So I have our miter box here, or the miter support that I just threw a piece of 3/4 inch ply on. we'll raise it up, set our miter saw in there, and try to figure out a way to clamp it so we can accurately indicate where it needs to get mounted to. So here's where we're at. The surface is level, front to back, side to side. It's sitting proud of the actual work surface by about 1/16 or so, but this is the only reference that matters. So how I ended up supporting it was 2 F-style clamps from Harbor Freight. I just reversed the heads, that way they're, you know, kind of acting like quasi jacks. And then I have some Bessie clamps back here supporting everything.
Now that I'm pretty satisfied with the placement of the miter support, I'm going to use a little offcut of the pipe and a hammer and give it a few little taps here just to leave a little indentation so I know where to drill the actual hole.
As you can see here, there's a small indentation where the pipe is going to rest at. So luckily I don't have to worry about relying on my drawing here because it's kind of garbage. So we got everything put together as far as the frame goes. The last thing we have to do is throw the top on it. Well, the last thing that we have to do as far as we're going to go with this current video. We'll talk about kind of future plans and stuff like that towards the end of the video. But while we're zoomed out, I wanted to give you an overview of how this actually functions, and then I'll bring you close up and we can see how everything is actually put together. So the saw flips up relatively easy, and once it's up, there's 2 barrel locks that secure it in place, and once the top is on, again it'll be flush with the top.
Taking a look underneath, you can see the little clamps I was talking about earlier holding the pipe there, and we ended up with about 1/8 of an inch clearance on either side. It's just those 2 little pieces of plywood that's supporting everything, and the actual side panels that run from top to bottom keep the pipe from moving out. So one of the main drawbacks of using lumber from the big box store is it's never really completely accurate. You know, I didn't joint or plane any of these, primarily because I don't own a joiner or a planer. So I'm a little bit out of square, so just apply a little bit of pressure with the clamps there, bring it into square, and then move the top over to basically hold everything once it's permanently affixed. So I'll line up the ends here, and then I'll move around to the far side where I left the factory edge, and I left it long on purpose. I'll take a line, or I'll scribe a line with my pencil, giving me 2 references that I can just connect the dots with to cut the excess off on the left-hand side there. I should have threw the clamps on there before I marked the end, but not that big of a deal. It didn't move, so threw some clamps on it. Now I'm marking what I need to cut out to allow my miter saw to flip up. With all my marks made, I just lay out my track saw guide and start ripping away. So I will have to make a couple plunge cuts. This is definitely one of the drawbacks of my saw. Since it's not riding on a fixed rail, you have to be pretty steady making your plunge cuts. Otherwise, you'll end up with a little bit of uneven cut. But it worked out fairly well, pretty satisfied. And then once I make all my plunge cuts, I just simply come back with a jigsaw and cut out the remaining parts that the circular saw couldn't get to.
So I went ahead and marked out where I'm going to put all my screws, keeping in mind where I might want to put T-track in the future. So we're going about 6 inches of spacing on the top into the studs using these 1.25" decking screws. The reason I'm using these is just because it's what I had. So, alright, the only thing left to do is just to pre-drill, countersink, and then run these screws in.
So here I'm using a drill bit and countersink all in one by DeWalt. I wish I would have had one of those countersink bits with the adjustable collar. That way you have a consistent depth. You know, there's different hardnesses, voids, etc. that you're competing with plywood. So you end up drilling some of your countersinks a little bit deeper than you intended to. But luckily I dropped this off the back of the workbench after finishing the video and broke my drill bit, so now I get to have a valid excuse for an upgrade.
Alright, so let's talk about the design of this thing a little bit. Everything works smoothly. I need to sand a couple spots. Right here, the latch is dragging when you're swinging it up and down. It's already wore its own groove in, so it's not that big of a deal whatsoever. I might just sand that spot down. Just for aesthetic purposes, really. The tabletop flips and it stores fine as long as it's at its 45 miter in this orientation, right? If you try to store it with a shelf in the bottom, flip the other way, the handle down here will actually contact the shelf, preventing it from going down all the way. That's not really that big of a deal. When I give you a walk around, I'll show you kind of what I was working with inside of this size constraints. So this empty space will be, I'll use the offcut of this piece right here, put some little ledges along here, along the sides to support the weight. Eventually, I'd like to get something a little bit more permanent and a little bit more stable. So with some extra scrap wood, affix it to here and put some threaded inserts so I can easily screw in and screw out the actual filler piece here. That way it gives me a more stable work surface. All right, so one of the things I had to consider was this, the bevel gauge, or the bevel adjustment on the back of the saw. As you can see, I have very little clearance going back here. So my original plan was to have this saw set further back into this. That way I'd have additional cutting capacity from the fence forward. However, I wanted the largest work surface that I could get that's permanently affixed, right? So this, the replacement piece in here won't be as stable as the actual workbench itself. So I wanted as much real estate up here as I could get, and then I would just work around whatever was left with the actual miter saw stand. So this is the compromise that I came up with, just pulling the saw as far forward onto the base as possible, getting it where I still have about 6 inches or so of rip capacity from the back fence here to the front edge of the workbench, completely unsupported. Now granted, once you get up here, this piece juts out and it'll give you additional support all the way up to this saw's actual cross-cut capacity.
All right, so here we're installing the supports for the replacement top once the miter saw is stowed. So just throwing some Type Bond original down, spreading it out, and then I'll put it where I want it. I'm using a small offcut of 3/4 inch ply just to make sure that it's smooth across the surface, and then throw some brads in it, and this will get repeated for all 3 sides.
All right, so let's talk about some pros and cons. Pros, it serves its purpose, right? So it offers me a relatively flat workbench to assemble stuff on. It easily converts into a miter saw stand to give me some increased accuracy on my miter cuts. And it's the right footprint. Cons, these casters from Harbor Freight, when you lock them, it doesn't lock the swivel action, so it can still move side to side a little bit. However, once you get it kind of set where all the swivels are in the same direction, you have to lean into it to get it to actually move. But considering they're $3 a piece, devices, $15 or more for the nicer locking swivel casters from Home Depot. I think I can live with that for now. Future plans going forward, on the far end here, I want to build some sort of flip up lane extension. I'd like to be able to get at least 60 inches from the fence or from the miter blade to the end of the extension fence. I don't foresee myself cutting anything routinely longer than 60 inches. That should be plenty in this space. I want to put some drawer slides, and then this will house fasteners and some of my more common work tools that I'll use on this bench, probably like my jigsaw, things of that nature. And then really down here is going to be pretty much left as is. I'll probably put some inset door hinges here just to clean up the appearance. Hang another 2x4 the same size across the top here, just to, again, make it look a little bit nicer. Alright, so I ended up sanding everything down, throwing 2 layers of satin metal wax poly on top just to give it a little stain protection. I ended up adding that piece of 2x4 to span the length of the little replacement top here, and just to keep a uniform, clean appearance across the top. I also ended up adding some little cutoffs here to underside of this replacement top, just to make sure that it keeps it a little bit more aligned as you slide it in here. Other than that, this build went together really well. I had a lot of fun building it, and I think it's going to come in handy definitely going forward. So if you like the video and if you're interested in more content like this, please subscribe to the channel. Thanks.